Hello everyone, welcome back to Algebra 51, Solving the Mysteries of Algebra. Today we're going to do section 1.7, which is involving solving absolute value equations and inequalities. Now today we're going to talk about the very first one, which is going to be 4x plus 2 absolute value equals 6. Now, when you're dealing with absolute values right here, now this right here can equal either, this whole equation here can equal either 6 or negative 6. Because if you take the absolute value of negative 6, it's going to equal 6 on the other side. So in order for us to figure out what x equals, we have to set this equation set equal to negative 6 and 6, because those are the both possibilities that this equation can answer. So we'll say 4x plus 2 equals negative 6. And then over here we'll put 4x plus 2 equal positive 6. And so as we do this problem, we're going to get a different result, because one's set to negative 6, one's set to 6. And those two answers will give us the proper answer, give us the solution for x. Now, so we'll go ahead and just solve for the first one. And we're going to do I like to do a blue when I'm doing solving. Solving here, we're going to subtract 2. And we're going to subtract 2. We do it on both sides of the equation like we talked before. And that's going to bring us down to 4x equals negative 8. And of course, if we divide both sides by 4, then x will equal negative 2. So that is one of our solutions. Now we'll come over to the other side. 4x plus 2 equals 6. We're going to subtract 2 on both sides. And we'll get 4x equals 4. Of course, you divide both sides by 4, x equals 1. And those are our two solutions. And sometimes you write this solution like this. X equal, it's 1, it's negative 2, and 1. I don't know if you've ever seen that before, but it's telling us the set of solutions that go with x. And that's what those solutions are. Okay, so now we know so there's our answer. The answer is x. You can write it either this way, and if you want to show off to your teacher, you can write it that way, because that's the way most mathematicians write that. All right, and let's see. Let's go on to now that is when this is what you call a absolute value equation. Now there's another one, and that's called the inequality. Inequality. Now, what's going to happen in this situation is you're going to have a different problem where instead of the problem being something, the absolute value is going to equal to something, it's going to give us it will give us two solutions, but they'll fall onto a number line. So let's look at this one here. We'll look at 2x minus 3 absolute value is less than 3. Now, we're going to set this equal to, now, this is going to be either 3 or negative 3. One way or the other. So we know it's going to be less than 3, and if it becomes negative 3, it's going to be to the other side. So we're going to say negative 3 is less than the absolute value of 2x minus 3. Absolute value is less than 3. That's how that problem's done. You set this, you know this is going to equal 3 or less than 3. So obviously if you set it to negative 3, it's going to be less than 2x minus 3. And it falls into a number line. And this is what you would call an and statement because it falls between two different points, and we'll see this in a minute. Now we're going to solve for this problem, and you know me, I'm always using blue. Okay, we're going to start off, we're going to add 3 here, and we're going to add 3 here, and we're going to add 3 here. And that's going to give us this will come out to be 0. And 0 is a number, so leave it there. Don't say, oh, 0, so we can drop the whole thing. No. 0 is on the number line. So, and that's going to be 0 is less than, and this right here cancels out, and it becomes 2x, absolute value. And then this, well, actually you don't have to put the absolute value, but I do it anyway. And then less than, this right here becomes 6. 3 plus 3 is 6. And then we divide the whole thing by 2, and this becomes divided by 2, and you can divide 0 by 2, because it just becomes 0, right? So 0 is less than x and less than 3. Either 2 divided by 2, boom, is x. 6 divided by 2 becomes 3. This is our answer. And on the number line, it would be like this. You would, on this one, you would have, with this, let's see here. For this right here, you would put this on the number line, and this would be 0. And then 1, 2, 3. If you want to show where it's located, this would be a -1, and you can put a 4 over here. I always put one little extra one to each side. And as we do this, we say, okay, we know that it's not a solid number. We're going to put a circle. We're going to put a hollow circle, a clear, open circle at 0. And I'm going to do that in red. Okay, and we're going to do it in red. Open circle. And then the other one is going to be at 3. Open circle. Meaning that everything inside this, everything is going to be equal to, it's going to be less than, but not equal to 3. So it could be 2.9999999. Over here it could be 0.0000001 and forever zeros, but the point is it's never going to be equal to 0, and it's never going to be equal to 3, but it'll be everything in between there. And that's how you write one of these. This is what you call, this will be like an AND graph. Okay. Now, so what we're going to do here is we're going to say 2x plus 7 absolute value is greater than or equal to 3. Now, of course, we know it could be equal to 3, or it could be equal to 3, or it could be less than -3. So we're going to write this as 2 separate equations. You got to solve the first one. The first one, let's put the bigger one on the right. Things that move to the right of the number line move to the right. So we'll say 2x plus 7. This will be 2x plus 7 is greater than or equal to 3. Now, if it's going to be less than 3, if we're going to do it, if it's going to be, if this whole thing could equal -3, obviously it would be less than. So we're going to set it up to be 2x plus 7, and that's going to be less than or equal to -3. See how that works? It's reversed. It's reversed because it's a negative. You remember how you multiply times -1? It reverses. It's the same principle. You're now dealing with the negative form of that, so you have to reverse the greater than symbol. Notice it's changed. Now we're going to come here, and I like to solve in blue, you know me. And I'm going to say we're going to subtract 7 and subtract 7. And this is going to be 2x is less than or equal to negative 10. Your 7 went away because of this, and then this, of course, 2 added 2 negatives, you got 10. And then you come over to here. Oh, wait a minute. We're not finished yet. Come over here. We're going to divide by 2. And so this becomes x is less than or equal to negative 5. Now come over to this problem here. 2x plus 7 is greater than or equal to 3. We're going to subtract 7. And that's going to make this 2x because 7's going to go away. Greater than or equal to. Now this becomes minus 4. Now, if we divide both sides by 2, and this becomes x is greater than or equal to minus 2. Now, if I had divided by a negative number, I would have reversed the inequalities, but I didn't. So everything was done by positive numbers. So that's all we had to do. We didn't have to do anything. So that's our answer. So the question is, how is this laid out on a graph? So we'll just take the graph here. Now we're going to say we got one of them's going to be a minus 2. Let's see. Let's do a minus 6 here. A minus 5. A minus 4. A minus 3. Minus 2, minus 1, and we'll just put a 0 here. And there's 1. Now, if we put in, now this is going to, because of this inequality having a line underneath it, means it's going to be greater than or equal to it. That means our line is going to be solid. Oh, I normally do that in red, don't I? I usually graph in red. Solid. And it's going to be less than negative 5. So it's going to go this way. See how that works? X is less than negative 5. Everything left of negative 5 will be x, including negative 5 because it's equal to it. Then we do the same thing here. X is greater than negative 2. So we know it's going to be greater than or equal to negative 2. And we know it's going to be greater than, so we're going to go to the right. And this is like one of your OR graphs. And that's how that's done.